a particle interacts with another particle gravitationally and changes the direction of the orbit. So one of the particles is approaching from the infinity. If there is no force acting between the two particles, this particle is following these lines. And the shortest distance between the two particles is a b. This is a b. We call it, this is the impact parameters. And at the infinities, this particle has a velocity of the u. And they are approaching to the other particles. And because of the gravitationally is attractive force, this particle is attracted. It's changing the direction and moving this direction. Okay, we'd like to consider this process is a scattering process. Then in this case, angular momentum and the energy have to be conserved. So angular momentum we have already discovered. So angular momentum, conservation of the angular momentum. At the infinities, mu, bu, this is the angular momentum at the infinities. And the energy is at the infinities, there is no gravitational potential. Gravitational potential is zero. This is also conservation of the energies. We could have these two equations. So if you know the u and the b and the u, so from this equation, if you know the b and the u, you can discover a and the e. So semi-major axis and the eccentricity is expressed as a function of the b and the u, using the conservation of angular momentum and energy. Let's move to the scattering process. So particles following these lines, then changing the directions. Then this is the original direction, and this is after the scattering process. The direction is changing by angle of the thetas. We call it this is scattering angles. Then f sub a, to express the asymptotes, f sub a is expressed cosine f sub a is a minus 1 over e. We discovered. Then scattering angle of these thetas we'd like to express. Okay. Then we consider tangent theta over 2. This is equal to tangent f sub a minus pi over 2. So this is f sub a. This is f sub a. This is pi minus f sub a. This is pi minus f sub a. So this angle becomes pi. So pi minus f sub a 2 times plus theta have to be equal to the pi. Okay, so theta is expressed 2fa minus pi. So theta over 2 is expressed f sub a minus pi over 2. So we use these relations here. So tangent theta over 2 equals tangent f sub a minus pi over 2. So this becomes sine f sub a minus pi over 2 over cosine f sub a minus pi over 2. So this you can use the addition formula. This becomes minus cosine f sub a over sine f sub a. And the sine f sub a is expressed cosine use a cosine square root 1 minus cosine square f sub a. And the cosine, you can use a cosine f sub a equal minus 1 over e. Then it becomes 1 over square root e square minus 1. Okay, so we could express the tangent theta over 2 it becomes 1 over e square minus 1. So 1 over e square minus 1. We can use angular momentums, conservation of the angular momentum and the energy to find out 1 over square root e square minus 1. Okay, from the conservation of the angular momentums, square root e square minus 1 is a mu bu over square root mu g m sub 1 m sub 2 a. Then we have from the energy conservations, we have equation for the a equal g m sub 1 m sub 2 over mu u square. This is the angular momentum. Conservation of the angular momentum. This is the conservation of the energy. Then you can just substitute this a here. Then it becomes mu b u squares over g m sub 1 m sub 2. So if you change the mu is m sub 1 m sub 2 over m sub 1 plus m sub 2. It becomes b u squared over g m sub 1 plus m sub 2. So we have an expression for the square root e minus 1. So we use this equation to the angles. So we discovered this one. So this equation is expressed g m sub 1 plus m sub 2 over b u squared. Okay, then we consider when u square is much larger than g m sub 1 and m sub 2 over b. This is really high, meaning the high speed scattering process. So in this case, tangent theta over 2 is much smaller than 1. So this means theta is less than, much smaller than 1, small angle scatterings. So when u squared equal to the g m sub 1 plus m sub 2 over b. So this case is a tangent theta over 2 equal 1. So theta equal pi over 2. So this process is a particle. Another particle is coming here, and the direction is changed by the 90 degrees. And scattered in these directions. Okay, so this is the end of this session.